Now there are two more functions that I want to talk about before wrapping it up, and that are the fallback function and the receive function, because they are equally important for finishing our project. Now, let me show you an example by just creating a new smart contract. Let's call this sample fallback sol, and then just add in the pragma and SPDX license identifier and call this contract sample fallback. Okay, as we heard before, we can send ether with message value. So why don't we just create an unsigned integer public last value send and no other function. You already know that if you have a function with a payable modifier, then you can send ETH there. But what if there is no function at all? What happens if you're going to send ETH there? So let's deploy this. And let's try to send one way to the smart contract by doing a low-level interaction. And by doing a low-level interaction, that will basically just send one single transfer, one single transaction, and the data field is going to be this one, but we're going to leave it empty. There is not going to be any data. So we are basically just sending a transaction from our account with one way to the smart contract address with no data. So if we transact, in order to receive ether transfer to the contract, in order to receive ether transfer, the contract should have either receive or payable fallback function. What that means is by default, the smart contract cannot receive anything. It just errors out. There's only one chance the smart contract can receive something, and that is by letting another smart contract self-destruct with this smart contract's address as a beneficiary. But we are not there yet. So let's just say in 99.9% of the cases, you cannot just send ether to a smart contract. You need to have one of the two specific functions. And there is a receive function and a fallback function. Now let's go to the receive function first. The receive function is a function that can receive ether, and it needs to be defined as receive external payable. And the problem with the receive function is it can only rely on 2,300 gas, which is really low. It's called the so-called gas stipend, because if somebody is sending a transaction without any data or anything to the smart contract, especially if another contract is interacting with this contract and just sending, an ETH or some value, then it will not have enough gas to actually do something meaningful. So normally you cannot even write a function or call any other function or write any storage variable. We are still going to do that because we are providing here enough gas. So we are sending enough gas to the smart contract with our transaction, but you cannot rely on it. So you should never rely on more than 2,300 gas. So in this case, we are just going to say last value sent is message value. But in order to also understand where this came from, we are going to introduce another variable, and we call this string public last function called. And we set the last function called to receive. Okay, let's just remove all of that. Hit the deploy. Nope. Hit the deploy button. Also, if the constructor is not payable, then you cannot send a value together with the deployment. So be careful with that. You just saw it erroring out in the background. The constructor is not payable. There is no constructor, so it's not payable. It's not payable by default. So you should have 0 value when you want to deploy a smart contract without a constructor. Okay, going back there, we can now send a way to our smart contract because we have a receive function. So let's just send it without any data. Hit transact. Oh, our function goes through. What is the last function called? It's receive. The last value, 1. We send one way. Perfect. What if we send actually some call data there? So let's just again add one way. and let's just 0x ABCD. What will happen? Oh, a fallback function is not defined. So what did we learn? We learned if there is no data, if there is just a value transfer without any kind of data that is sent to the smart contract, then it will automatically hit the receive function. Otherwise, if there's a call data, it will need a fallback function. So the way this works is by defining a fallback external. So the payable here is optional. Why is it optional? Now, if you want to have a function that gets called in case no other function matches the data encoded signature, function signature, and I will tell you in a second how that works, then the fallback function will be called. If you want that fallback function to also be able to receive any value, then you add the payable modifier. So in this case, let's run with this one. Last value sent is message sender, and last function called is fallback. Also over here, be careful because it cannot get more than value. Obviously, it cannot get more than 2,300 gas usually, or you shouldn't rely on more than 2,300 gas. So writing to any storage variables is a bad idea. What you can do is send an event or something. Now let's redeploy this. Again, 0. Deploy this, and then send one way to our smart contract without anything. Let's receive, and now let's add some data and add two-way over here. Transact, now it works. And the last function called is fallback, and the last value sent is 2. We send two-way. Now the question is, what if we have no receive function, but we have a fallback function and we don't send any data? Now the way this works, let's just quickly deploy this. Add one way, no data, transact. Now it calls automatically the fallback function. So if you have a fallback function that is payable but no receive function, then no matter if there is a call data or there's a data sent, it will call the fallback function. If you have both, then there is no data, it will call the receive function. If there is data, it will call the fallback function. If you have no fallback function but a receive function, then it will be only possible to send ETH to the smart contract without any call data. Now, this is where the signature, the function signatures comes in. And I will also tell you more about this in the next lecture, but let's just roll with this. Now let's add another variable called uint public my uint, and then add a function set my uint my new uint, and we are going to set the my uint to my new uint. Okay, let's just remove all of this, deploy the smart contract, and let's call this with 1. And let's open this. Have a look at the input data. I'm going to copy this over here, and I'm going to just paste it that you see how this looks like. You see the input data over here? That is specially coded to make the EVM understand what you actually want to do. Now the first 4 bytes, that one is the 0x to show that it's a hex value. The first 4 bytes, 1, 2, 3, 4. So the first 8 hex characters are the function signature. And this is how internally the EVM understands what kind of function it should call. That is the identifier. And the way you get to that is by making the Kesa cache of the function signature. The function signature over here is simply set my uint, the name, plus the type that it actually expects, uint 256. You know, that's an alias for uint 256. And if you take the Kesa cache of that, free utils SHA free, Scroll down. Where is it? Then you get this large string. And if you have a look at the first 4 bytes, then that is the function identifier. So the rest, it will be thrown away. This is how internally the EVM knows what kind of function it should call. Now, if you take the raw data over here, let's just comment this out. If you take the raw data field that we set before and just insert it into call data and hit transact, then the function will work perfectly, because it will call the same function. It will call the, where is it? The setMyUint function. And Remix even knows that, because it can decode, or it can map this 4-byte or 8 hex characters function identifier from this function signature to the actual function. Now you can also modify this this data, because it's just an unsigned integer 256 with zeros padded to the actual length of the variable. So if you just hit here 2 and you ask what is my uint now, it's going to be 2. So this is how this works. In the fallback function comes in if it doesn't know where to go. So let's say we have this one as a function identifier. There is no such function, so it's going to call the callback function. This is where the fallback function will come in. So I hope this was helpful, and let's wrap it up, and then let's get our project going, because that's going to be very exciting now.